yesterday I wrote that. That was Rolle's theorem. So that should be the notes, right? That's not new. Like, you don't have to write that. I'm just showing you what it was. So all I'm going to do... Why did that just happen? What is going on?
It's pretty.
It's, yeah, great. Well, we're going to try Google Doc here. Okay, so that was yesterday. Rolle's theorem. I'm just going to change. So yesterday we said, if continuous and differentiable, and the slope between the two x values is 0, there must be another spot where the derivative equals 0. Mean value theorem is just a bigger picture version of that. So I'm just going to change things. Mean value theorem, and it is for derivatives because there is also the mean value theorem for integrals is average value. Mean, average, like that's what we did a couple days ago. So the mean value theorem for derivative, if I generalize this more, if f of x is continuous and differentiable, that still has to be true. And again, so let's go through these again. F of x means it has to be a function, so what does that mean as far as a graph? It can't go back over itself. Continuous, what was the rule that I made you follow when you drew it that means continuous? Can't pick up your pen. And differentiable, can't have any corners. So if all those things are true and the slope between two x values a and b equals anything, let's say k, it doesn't matter what I put there, then there must exist at least one x value, we'll call it c, where f prime of c equals k. The exact same rule, just a bigger picture version of it. Yesterday was like a specific subset. So I'll fix this part down here in a second also. Is that big enough? People in the back, can you see it? Yes, no? Somebody speak? Okay, thank you. Nobody spoke. People just give me a thumbs up. Galen, you're good with your picture. Okay. So then if I want to fix this bottom piece, what am I putting where the 0 was? The slope between the endpoints is k. There must be at least one other place where the slope equals k. You can put whatever you want there. If the slope between the endpoints is jerk face, there must be at least one other spot where the slope is jerk face. Yeah, the mean value, yeah. Nice. Just gotta look up when you're done, so I know we can. Because I don't want to move the screen until people are done writing. You alright? Good? Alright, so let's do some problems. Same exact thing as yesterday, except there's a step beforehand now. Because yesterday, what was the slope every single time? Slope was 0 every time. Well, now it's not. So I have to actually find the slope. So there's an extra step here. Because the slope isn't necessarily going to be 0. And you're not going to have a graph for every one of these either. So when we first started, there'll be a graph so you can see what's going on. Monday we'll probably do this same type of thing again, but there's no graph, so you can't see this one, -4 to -1. -4 is here, -1 is here. Is the function continuous and differentiable in between those two spots? Yep. It's smooth, there's no corners or anything. So what the mean value theorem says is there has to be a spot where the derivative is equal to that slope. Well, first we gotta find that slope. So these are a little more annoying, you have a little more work to do in the beginning. So I've got to find the y value for each of those two spots, those two x values. And then find the slope between. So start with that. Find the y value for each of those. Which, how do you do that? Plug in x to the original. And then find the slope between those 2 points. And then we'll go from there. Not enough to get you started. We good? Some people gave me a weird look, but those people seem to be writing now, so I think we're okay. Skip. Plug in -4. -4 squared is 16 minus 4 is 12 over -16. So this is -3/4, so you reduce that. I plug in -1. I'll get 1 minus 4 on top, so -3 over -4, so that's 3/4. Is 3 of my y values. Find the slope. So y2 minus y1. So I always do like the bottom minus the top. So it'll be 3/4 minus -3/4 over -1 minus -4. So those are both plus plus. So this is 6/4 over 3. But I don't divide fractions, right? So I don't do 6/4 divided by 3. I do 6/4 times 1/3, which is 6/12. Which all of that was just to find that this slope here is a half. Do we agree with that part? Slope is a half. So what does the mean value theorem say then? There's another spot where the slope equals a half, so I find that. Take the derivative. It's not equal to a half. Do that. You have to do your own notes. When we were setting it equal to 0, the bottom disappeared, right? It doesn't haven't solved this one yet, but remember if you have a fraction equal to a fraction, you can always cross multiply. I feel like that's going to be helpful in this situation. I haven't gotten there yet, but keep that in mind as a possible strategy. If you have fraction equals fraction, you can cross multiply. Just like one diagonal equals the other diagonal. One to cross equals it. Questions on me getting to here before I keep going? Where'd you get this? How this happened? Anything up to this point? So then I would combine these two and say, okay, that's really 4x squared plus 16 over 16x squared equals a half. And now this is where I would cross multiply. So I would do one diagonal equals the other diagonal. So 1 times 16x squared is 16x squared. 2 times that entire quantity will give me 8x squared plus 32. And with quadratics, I want to get all the x squared and everything on the same side. You can do that with this one. You can also kind of shortcut it, but let's do that because that's what I usually tell you. So if I bring everything over, this would be 8x squared minus 32 equals 0. See what I did there? What can I factor out here? Factor out an 8. X squared minus 4 equals 0. And then what does x squared minus 4 factor into? X plus 2x minus 2. And then that gives me x equals negative 2 and x equals 2. Which one of those do I care about? The x equals negative 2 because that's in the window here. And so negative 2, so right at that spot right there, if I drew the tangent line, I know it's really small, but hopefully you can kind of tell that would match up a little bit there. So that's your answer, x equals 2. Questions on that one? How many worked out of me and got x equals 2? Or negative 2, sorry, negative 2. Yeah.
So on this one, the graph does not have to be continuous overall like that. It just has to be.
Not overall, just where we're looking. So I can like zoom in my window and be like, okay, here it's continuous. Let's look at here.
That's true of the other one too, right?
Yes. Okay. But if in this graph I said like from negative 1 to 4, then it's ruined. I can't do it anymore. If I cross over that continuous part, then I can't do it. Other questions on this one? Make sense? Yeah.
What was we were talking about shortcut?
So I could in this one just bring that over and go, okay, that's 8x squared equals 32. Then divide by 8, get x squared equals 4. The problem I have with this is people square root the 4 and they're just like, oh, it's 2. They stop. They forget that it's really 2 and negative 2. And then that negative 2 is actually what we needed, But if you remember to do both versions, it's okay.
Yeah, I forgot that square root needed plus or minus.
Right, so that's the problem. Where if I make you factor, it kind of forces you to remember. Alright, can I erase?
Yes.
Let me move to the next one. You guys start writing it while I'm erasing. Yeah, that's good. What is that? So I'm just going to say go and try it. I'll work through it after you. Try it on your own first. Just find the slope first. That's setting the derivative equal to the slope. you should have 3x's for that. Okay. I'm not getting them today anymore. So we haven't switched. We just got all the sketch marks.
Yeah, we were. Yeah.
Is it -2 for the slope? It's a good start. I'm going to take the derivatives and sum equal that. You didn't get that? I got a question. Let me know. I would crack up on that. But you could just take a 2 out of all 4 of those, because you'd take a 2 out of here and you go down there. Oh, no one's there shouldn't be summer breaks for that. The best way to learn it would be like 4 days a week. I don't want to, but that's way to do it. That's right. Freak out because of the square root.
Yep. Oh.
So I got bottom times derivative of top minus top times derivative of the bottom over the bottom squared. This gives me -4x squared. This will give me plus 2x squared minus 18 if I multiply these three things together over 4x squared, and that equals -2, which I'm going to throw that over 1 because I feel like I'm going to cross multiply in a second. These I can combine, so that's -2x squared minus 18 over 4x squared equals -2 over 1. Then if I cross multiply, so this will give me negative 2x squared minus 18 equals negative 8x squared. And then again, you get to this, okay, I can factor, or I can like move things to each side. I'm going to bring it over and factor, just because I think it's a little tougher way, so I want to show you. So if I add 8x squared to both sides, I get 6x squared minus 18 equals 0. What can I factor out of both of those? 6. And then, so this is where it gets a little bit goofy. You know, if this were like x squared minus 16, for example, you would put a plus 4 and a minus 4 here, right? If this were x squared minus 100, you would put a plus 10 and a minus 10 there. So you're taking the square root. So if it's a 3, what can you put there in there? Positive square root of 3 and negative square root of 3. So you're doing the same thing. You're taking the square root of that number, putting it in both those two spots. You know, like x squared minus 100. X plus 10, x minus 10, right? So in general, x squared minus a squared becomes x plus a, x minus a. So we did this way back with limits a little bit too. So if that's a 3, I can put plus square root of 3 minus square root of 3 in those two spots. Some of you might solve it different, where you put the x squared on one side and the 3 on the other side, and then square rooted. Just remember both answers in that case. So this gives me x equals negative square root of 3, and x equals positive square root of 3, and which one do I care about? It's the negative square root of 3, because that's the one that fits into this window. So that's somewhere around here, we're going to have that parallel slope. Questions on that one at all? How many got to that before I went through it? I might have gone too fast. Anything I can help with? So one more thing, just to keep in mind, make sure that it qualifies first. So, for example, if I look at that one, can I even do the problem? I cannot, because I'm going from negative 1 to 3, and in between negative 1 and 3, that's not continuous, right? So you're going to get something like that. I think there's 2 or 3 on your worksheet that you just can't do, which is fine. I just want you to know that you can't do them. So that's your homework.